Let's talk about a way how we can get some formulas. Well, for example, sine of x plus pi over 2 is equal to cosine of x. How about the cosine of x plus pi over 2? We can get this formula by differentiating the known formula with respect to x. Well, in the left side, let's see, the derivative of sine of x plus pi over 2. Derivative of sine is cosine, and cosine will be evaluated in that point. And if we look at this inner function here, its derivative is 1. So that's okay. That's the derivative of the left side. And we know that this is equal to the derivative of the right side. The right side is cosine of x, and derivative of that is minus sine x. So we got our formula. It can be proved that sine of x plus y is equal to this. How about the similar formula for cosine? If we differentiate the left side with respect to x, we will get cosine of x plus y. Now here we can think that this y is here a constant. While differentiating with respect to x, let's keep y as a constant. If we differentiate the right hand side with respect to x, what will we get? We will get sine of x will become cosine of x, then we have cosine of y, then cosine of x will become minus sine of x, and sine of y will be a constant. We obtained our formula. So this is very useful. Many times it is enough to remember one formula, and from that formula we can generate similar kinds of formulas. Let's a little bit continue. How about if we take this formula and we differentiate with respect to x? In the left hand side we will get the derivative of the natural logarithm is 1 over x, so we have 1 over something, and now the argument is x times y, so x times y will come here. The derivative of the argument is now with respect to x is now y, and it seems that these y's will cancel out and we just get 1 over x. How about in the right hand side? If we differentiate this with respect to x, what will we get? Well, the derivative of natural logarithm of x is 1 over x, and this natural logarithm of y is a constant, so its derivative will be 0. So we got that 1 over x is 1 over x. Well, that's good. It shows that everything is okay. There will be 2 videos discussing the partial derivatives. Here are 2 differentiation rules. Here is an example about partial differentiation. If we differentiate x to power y with respect to x, then we can use this first formula and we obtain that it will be equal to this. But on the other hand, if we differentiate x to power y with respect to y, then we will use the other formula and we will obtain natural logarithm of x times x to power y. Yeah, that's all. It's very nice to be able to differentiate with respect to any variable what you have in the formula.